Okay, so I'm going to do a quick video for you on how to calculate density and how to analyze density. So density is mass divided by volume. Okay, and so when you are trying to find the density of an item, you have to find the mass, and this is going to be in grams. And then you have to find the volume. Now, there's actually two different ways we can find volume, and I'm going to talk about both so you remember them. Volume can be milliliters or it can be centimeters cubed, and I'll explain that right now. So if I gave you an object, and let's say it's a cube, and I said, can you find the mass of the cube? You could walk over to your electronic balance, and you could put it on there, and you could hit the button, and you get the mass, and then the number comes up, and we'll say it says 13.2 grams, okay? That's going to equal your mass. So now you would have your calculation, so density, so we're going to put 13.2 grams on the top. We need our volume. This cube is nice and neat, so we could actually find volume two different ways. First way is we could have our graduated cylinder, and we could put water in it. We'll fill it up just enough that it would cover the cube if I put the cube in here, but not so much that it would go out the top. All right, so whatever measurement that is, before you put the cube in, you measure it. So let's say it says 12.1 milliliters. And then you put the cube down in it. And naturally what's going to happen is that water level is going to go up because the cube has volume, and volume takes up space. Just like if you were to sit down in a bathtub, all the water would kind of move out of the way around you. And so if you take up more space, then the water's going to go up higher and higher. So that final measurement, let's say it says 14.1, that final measurement is not the volume of your cube. It's when you subtract the two measurements. So 14.1 milliliters minus 12.1 milliliters. So 1 minus 1 is 0. 4 minus 2 is 2. 1 minus 1 is 0. So that cube actually has a volume of 2.0 milliliters. All right, and so then you would take your calculator, and you would do 13.2 divided by 2.0. You're going to get an answer of 6.6, and then your units are based on this set of units. There's not a new unit for density, so it's grams per milliliter. Now, the cube can actually, the volume can be found a different way. Because of the shape of the cube, you could have actually taken it to the side and taken a ruler and measured the three dimensions of the cube. So 1, 2, and 3. Okay, so whatever they were, and you would multiply them. I don't know what 1.1 times 1.1 times 1.1. I have no idea what that's going to be. I don't think it's going to be 2, obviously, but let's do 1.1 times 1.1 times 1.1 should be 1.33. Okay, so that would be 1.31 centimeters cubed. So length times width times height. All right, so that is another way to find volume. So let's say this cube. So let's see. We put it on the scale, move him off, put it on the scale. We would find this cube's mass, and let's say this one's bigger. We'll say it's 24.2 grams. And then we divide it by the volume that we found, 1.331 centimeters cubed. Now when we multiply, 24.2 divided by 1.331, you're going to get 18.18 repeating, and then it's going to be grams per centimeters cubed. All right, so the units look different on those two, but it's fine because whether you use centimeters cubed on the bottom or milliliters on the bottom, depends on what piece of equipment you use. So if you used your graduated cylinder, the volume has units of milliliters. If you used your metric ruler, it's going to have centimeters cubed. Both of those are densities. And what this tells you is that this has a lot more particles packed together per milliliter or per centimeter cube because it's 18.18. This one's 6.6. Okay, so 18.18 cube is made of a totally different substance, and that substance is more dense than the first block. So the green block is more dense than the purple block. Now, the last thing I want to show you is what you can do with these numbers and how you can estimate things. So, in a graduated cylinder, and you want to find the volume of it, there are some objects that you cannot use this method, and this method of putting water in and then putting the item in and then seeing how much the water level moves is called volume by displacement. And so if you put an item into this graduated cylinder and it floats, you really can't do density of it because the item has to actually sink so that it's covered by water. So how do we decide what will sink and what will float? Okay, so it's all based on density. The density of water, and I'm going to make that the density of pure water, is 1.0 gram per milliliter. So what that actually means is really cool. So if I had 62 milliliters of water, then I know that its mass is also going to be 62 grams because its density is always equal to 1.0. And the only time you can get 1 from a fraction is when the top and the bottom are the same. So anytime you are dealing with pure water, the mass and the density, the mass and the volume should be the same amount if you're measuring it correctly. So 1.0 grams per milliliter is the density of pure water. Now, that's how we determine if things will sink or float. If I have an item that goes down, and I put my water in my graduated cylinder, and I have an item that goes down to the bottom, then I don't know its density just right off the top of my head, but I know that it is equal to, it's greater than 1 gram per milliliter. Why do I know that? Because if it's bigger than 1, it sinks in water. Anything that floats at the top is going to be less than 1 gram per milliliter because it's going to be less dense than water. So this is more dense. This is less dense. And then if I happen to put an item in here that has a density of 1.0 also, it will kind of float halfway in the middle of the water because it has the same density. And so you can see these different things in little stores where they have objects that float and sink and kind of are suspended in the middle, and it's all about the density. Now, if I change the substance and I didn't use water, if I used vinegar, vinegar has a different density, or if I used cooking oil has an absolute different density. So based on the liquid that the item is floating in, it will sink or float based on how dense it is. All right, so I'm going to give you some worksheets to do. And one of the things I'm going to have you do is I'm going to give you some different items, and you're going to calculate their density, and then we're going to put them in place in the graduated cylinder. So what I want you to do is I want for you to draw a graduated cylinder, draw it better than me, on your paper. And then I'm going to give you a couple of items. So that's a circle, that's a square, that is supposed to be a triangle. This is a star. And then, we'll let the next one be a little swirl, okay? So I'm going to give you their mass and their volume, and then I want you to put them in the graduated cylinder based on where they would fall if you stuck them in the graduated cylinder. Okay, so for your square, I'll create a table for you. So it's going to be mass and volume. This one was 9.2 grams, and so you'll pretend like you went over and found the mass. This one was 8.9 grams. This one was 16.93 grams. This one was 21.9 grams. And this one was 0.99 grams. Okay, so that's your mass. And then your volume for your different items, you would have, let's see, 7.8 milliliters. I'll let that be milliliters and let this be grams. 3.5 milliliters, 16.93 milliliters, 0.07 milliliters, and then 1.32 milliliters. Okay, so those are your mass and your density. Your mass and your volume. So what I want you to do is calculate their density. You can set that up in a better table than I have. And then I want you to put the items into a fake graduated cylinder, so you would draw them. So if you think it would sink, you put it down at the bottom. If you think it would float, you put it up at the top. And then that way, when you come in to class the next time, I'll check your notes and we'll see, do you understand where items would be in a graduated cylinder based on their density? And remember, density, if I was to look at two blocks and all the particles were tightly packed together, now you'd have to have a very high power microscope to see that. And then the particles are just like loosely and lightly packed together. This one would have a higher density and this one would have a lower density in comparison to each other. And we'll talk about our human body, like how dense we are and what happens to us in the water, because some of us float and some of us sink. And it has to do with how much muscle we have in our body and the water that we float in. All right, so do your calculations and put them in your test tube, and I'll see you next time.